You probably recognize this equipment as components of an electrical grid. You likely have something similar on utility poles in your neighborhood, bringing electricity to the homes and industries in your community. You may be interested to know that the technology mounted on this pole was at the center of an epic battle between the competing theories of the famous American inventor Thomas Edison and an obscure Serbian academic, Nikola Tesla. Tesla's theory won. Here's the story. In the late 19th century, Edison had become a household name, known around the world. His inventions and innovations covered everything from telegraphy and the movie camera to the phonograph and the light bulb. By the time he was finished inventing, he held over 1,000 patents. He was brilliant at not only innovating, but also at business. Edison turned his inventions into commercial successes. In the case of the light bulb, he created a complete power system, generating electricity and delivering it to customers, energizing their light bulbs. Edison's system typically used a steam engine to drive a generator, creating direct current electricity. This is an Armington and Sims steam engine. Edison purchased hundreds of these to turn his generators. Steam engines like this were fueled with coal, wood, or oil. This miniature steam engine demonstrates the process. In this working model, electricity heats water, producing steam. The pressurized steam is controlled by a valve system to drive the piston back and forth. A connecting rod from the piston connects to a crankshaft. This device converts the oscillating linear motion of the piston to a rotary motion, turning the flywheel. A valve controls the speed of the engine. This is a generator. Permanent magnets surround coils of wire. The coils rotate in the magnetic field, inducing a flow of electricity. In this miniature generator, the electricity flows through the filament of a light bulb. A drive belt connects the flywheel to the generator. Once it is up to speed, the filament glows. Electrical energy has become light energy. Edison's generators produce DC, or direct current. This means that the current, a flow of charged particles, usually electrons, always travel in the same direction, from one terminal of the generator through the load, in this case a lamp, to the other terminal of the generator. Battery cells also produce direct current. Electrons flow from minus to plus. Edison built hundreds of DC plants around the world. He realized that there was a huge market for electric light. But there was one technical problem he had not resolved. The electricity lost energy as it traveled through the wires. Once the wires from the generator exceeded 2 kilometers long, there was not enough electrical energy left to turn on a light bulb. Every customer had to be within 2 kilometers of the power plant. This phenomenon was called line loss. A serious problem for Edison. There was no obvious solution. Nikola Tesla, a Serbian electrical engineer, arrived in America in 1884. He brought with him the solution to Edison's problem. Tesla was an engineer and mathematician. He understood the science of the day, including Ohm's law and Joule's law. Mathematical descriptions of the relationship between voltage, current, resistance, and power. Joule's law reveals Edison's problem. This simple formula, power equals current squared times resistance, tells us that the power lost when current flows in a wire is equal to the resistance of the wire times the current squared. Current is represented by the letter I and is measured in amperes. Resistance is measured in ohms, and power in watts. Most of the power lost becomes heat. The wire gets warm. As you can see, resistance in the conductor is one factor in line loss, but current affects line loss exponentially, I squared. Reducing current without reducing available power would solve the problem. There is a way to do this. We can rearrange Ohm's law to state that R equals V over I. Substituting V over I for R in Joule's law, we get this. Power equals voltage times current. Here is what this means. Low voltage and high current can produce exactly the same power as high voltage and low current. 100 amps times 10 volts represents 1,000 watts of power. 2 amps times 500 volts also represents 1,000 watts of power, with the advantage of a small current traveling in the wire. Edison knew that higher voltages and lower currents would resolve the line loss problem, but high voltages were dangerous. There had already been some deaths when experimenting with this solution. It was not possible to safely deliver electricity at 1,000 volts or more into homes. He had no solution to the I squared R problem. The solution that Tesla proposed, a solution rejected by Edison, was to abandon direct current and develop an electrical grid using alternating current, AC. Unlike DC, alternating current doesn't flow constantly in the same direction. It changes direction, surging back and forth. Alternating current is easily produced with a special type of generator, and AC has some very interesting properties. This surging back and forth motion of the current produces electromagnetic radiation that can induce current flow in adjacent but unconnected conductors. Tesla understood this radiation and perfected a device capable of changing voltage and current in an electrical system, the transformer. This changed everything. Suddenly it was possible to deliver electricity hundreds of kilometers using high voltage, low current transmission. The low current reduced line losses dramatically. The wires carrying the high voltage were suspended on towers at a safe height. The final step in this brilliant solution occurred when a step-down transformer converted the electricity back to a less dangerous low voltage with higher current for use in the homes and industries of the community. The relatively short distance from the transformer to the home meant that line loss from the higher current was minimized. Tesla had found a solution to the line loss problem. Edison realized he had a problem. His direct current systems were in trouble. He launched a bizarre campaign to discredit Tesla, even holding public electrocutions of animals to demonstrate the dangers of alternating current. But in the end, even Edison's wealth and reputation couldn't defeat the math and science. Tesla won. He solved the I squared R problem. You won't have to look further than your front yard to see Tesla's alternating current in action. This transformer in front of our house is converting the very dangerous thousands of volts on the supply lines to less dangerous 120 volts for use in our home. Alternating current electrical grids cover the globe, delivering power from a multitude of sources through an interconnected network of transmission lines and transformers. This is Tesla's vision of electric power transmission realized. Innovation with alternating current is just one aspect of this amazing man's life. Visit our Tesla website at hylaroad.com/Tesla to learn more about his accomplishments. And for additional science videos and projects, visit our website, hylaroad.com. Follow the project's link.